Hi guys, welcome to the session 28 of Java Full Stack Made Easy. Previous session we discussed about the queues. So in this session we will be talking about the maps in a collection. And in this session particularly we will be talking about a hash table and a hash map. Also we will see how can we traverse over a map. So let's go ahead and first let's see what have we discussed till now. So till now what we have done is we are done with the concept of list, queues and the sets. Fine. So if you look at the hierarchy of collections in Java, what we have is we have this list, queue and set under the collection and they are all iterable. Fine. So whereas if I look at the maps, if I see the hierarchy of a map, it does not belong to the iterable interface, right? So it's separate, it's not in that particular hierarchy. So the top level class is top level interface in a map hierarchy is map. So from the map, hash table and hash map is the implementation, direct implementation, and then there is a sorted map which is an interface again. That means it is a child of a map, and again we have a navigable map which is a child of sorted map. So out of that there is a class, the class is implementing a navigable map which is a tree map. So tree map is sorted by default itself. Like we have seen, priority queues are sorted when it comes to queues, and when it comes to sets, we have seen the tree set is sorted, right? So in this session we will be talking about the hash table and the hash map, which is the direct implementation of a map implementation. After that we can go ahead and we will talk about the linked hash map as well as the tree map in the next session. So in this session let's focus on the hash table and the hash map. Fine. So here we go. Let me first clean up. I'll create a new class itself for the maps. Fine. So let's call it as a map demo. Let's create a new class. Let's call it as maps demo. Let's also include a main method inside it. Now while creating the maps we should be aware about few things about the maps, like a few things we have discussed about the list, set and the queues, right? List can contain duplicates, maintains the order. Similarly with the sets we have seen that it contains unique elements, does not guarantee you the order. In the queues we follow the first in first out concept. So likewise, what are the functionalities, what are the key features of the map, right? So let's discuss that. First of all, the maps contain a key and a value pair. Okay, so this map data structure contains a key and a value is associated with a key. And now the rule is that keys are unique. That means keys cannot be duplicated. So this is an important point that we have to remember. Keys are unique. Keys cannot be duplicated. Fine. And also in the later part we will see like which of the map allows null key, null value and all that. We will see that in details when we are talking about the different type of maps, because each of the map will have its own functionality, right? We have already discussed that the same thing with the sets, same thing with the list, as well as same thing with the queues, because different implementation have different behavior. So the main behavior about the map is that it contains a key value pair and the keys are unique. Fine. So as discussed in this session, we will be talking about what? We will be talking about the hash table and the hash map. Okay. So now one important point that comes up into our mind is that where this concept of key value pairs, the mapping concept is used. I'll give you one simple example to understand that. Let's say 586101. That's the pin code of city Bijapur. Right? So each city has a pin code. So to identify a city we take a unique pin code. Similarly in such scenarios we can take what? We can take a map. We can set the key as 56101, which is the integer value, and then Bijapur, the string value, as a value for it. Okay. So a key value pair. Or what we can also do is we can have a captain, and under the captain the players. So whichever captain you search, you'll get the players there, or maybe a team and players in that particular team. So that way we can create maps. So if you just search for a team, all the players of that particular team will be retrieved back to you. So this is the situations where maps can be used. Hopefully I was able to make you understand what exactly, where are the maps being used in real time. You can also say that you search for a library and the library gives you all the books available into the library. So in such situations also map can be used. Okay. Alright, so let's go ahead and create a very simple map and see how a map behaves. So I'll create an instance of a map. Now what am I thinking of in terms of a map is that I want to give a ID, player ID, that is the jersey number and the name of the player. This is the concept that I generally follow, right? So let's take a map which will have an ID, player ID, that is a jersey number, which will be of type integer, and the name of the player, which will be of type string. Let's call it as players is equal to new. Now as of now I'm creating a hash table. Okay, main difference between a hash table and a hash map is hash table is thread safe, hash map is not. So because hash table is thread safe, it is going to be slow for sure. Hash map is not thread safe, then obviously it is going to be fast. And whichever is slow, it is safe. And map is fast, but it is unsafe. So hash table will be used when you are working with a multi-threaded application, whereas hash map will be used when you are using a single-threaded application. Alright, so I have created a map and I have called it as players. Now I'll say players dot. So usually we do a add method, right? To add an element into a collection, we always use the add method. Since this map is not a part of that collection and iterable hierarchy, you don't find an add method there, right? So if you look at the hierarchy here, map is there, right? Map is there, but it's not a part of this hierarchy that we have discussed here, which is an iterable and collection and all that. It's not a part of this. It's completely different, right? So because of that, we don't have these common methods available into the map. Fine. So those methods like add and all will not be available here. So how do we add an element into the map? That is the very first question. And also here we will be discussing about some of the key methods, frequently used methods available into the map. The first method is the put method, that is used to add the elements into a map. So since my map is of type integer comma string, so a put method gives me an integer key and the string value. So let's go ahead and add the integer key and the value. So 18 is the key and I want to give a string value to it, Virat. I added the element into it. Similarly, I would like to add some 2-3 elements into it. Fine. So I'm adding 45 and I add Rohit, and then I add 10 and let's add Sachin, and also let's add one more in this. So jersey number 1, Rahul. Let me save it. So I've added 4 elements into this map and I want to check what all elements are available into the map. Fine. So let's go ahead and just see what elements are there into this map. So I'll use my old way, system.out.println, that is just the map. Okay, let's see what is there which is available. So I'll run this and you can see 10 Sachin is there, 18 Virat is there, 1 KL Rahul is there, 45 Rohit is there. So that are the elements that are available into a map. Now that I am printing that particular map and giving you the elements into a map, check the elements. Is it maintaining the order in which I have added the elements? No, right? It does not maintain the order in which I have added the elements. So which means that in hash table it does not preserve the order. So obviously in future we will see maps maintaining the order, also maps being sorted. Fine. So as for now we are talking about the hash table which is thread safe, and it does not guarantee you the order of the elements. So I've added the elements by using a put method, and then I'm printing that data. Then one more important method we will discuss here, that is the get method of a map. So I'll do a system.out.println. What we can do is we can do a players.get. If I pass a key, we get a value. You can see it here, get method. So you pass in a key, you get the value. So my key is what? This 18, 45, 10 and 1. This is my key, and these are the value associated with it. So I pass the key as 10. So I'm expecting the value to be printed here is Sachin. So the get method takes the key and gives you the value, right? So two important methods of a map implementation we have discussed, that is the put method, which is used to add the element into a map, then the get method, which is used to retrieve the element from a map. So I'll put this particular demo, a very simple map demo, into the repository first. So let's go to our repository, and this is our session number 28. Let's create a new repository for it, call it as day 28. Demo 1 hash table, and we are using a put method and a get method. Two things we have used here. Fine, done. So looks good. So now go for hash table versus hash map. Okay, so one main difference we have already discussed: hash table is thread safe, hash map is not, right? So let's see the differences. So hash table thread safe, hash map is not. So that means methods are not synchronized here. Here it is synchronized. Fine. So single threaded application, we should be using hash map. Multi-threaded application, hash table should be used. It's the same thing. So it's all about the threads. Null is allowed for both key and values for hash map, and null is not allowed for both key and values. Otherwise we will get a null pointer exception. So now we are using a hash table, right? So which means here we cannot have either a null key or a null value. So let's test that as well. So I'm trying to add a null. I'll try to add a null key first, and then I'll try to add a null value. Players.put. I'm adding a null key and I'm giving some value. Test. So I'll save it as no error at all, no compile time error. Let's run this, and here we go. We get a null pointer exception. Null pointer exception. So I'll comment this, and now I will try to give a null value. So let the key be 12, value null. Let's save it and try to retrieve again a null pointer exception. So in a hash table, neither a null key is allowed nor a null value is allowed, whereas hash map allows that. So when we are writing hash map, we will test it there. Okay, null is allowed for both key and the value, and we will see how many null keys are allowed and how many null values are allowed, right? So these can be our interview questions again. And the hash table is a legacy class because it was added right from Java 1.0, whereas hash map was introduced into Java 1.2. Fine. Next. So let me first put this into the repository. Hash table does not allow null key or a null value. Demo 2 hash table null key null value. Neither a null key is allowed nor a null value is allowed into it. Now the next point is that since it is not a part of iterable, right, how can we iterate over the map? So that will be one important thing which we should be discussing about the maps, because up till now what we simply did was we used a enhanced for loop and then we iterated over a collection, any collection, be it a queue or a set or a list. Now how do we iterate over a map? Because map has a key and a value pair, and it does not belong to the iterable hierarchy. Let's see how do we do it. So there are basically two methods available for iterating over a map. Again, those two methods are keySet and entrySet. We will see both. How do we use a keySet and how do we use a entrySet? So let me first go for a keySet and then iterate over a map and show you how do we do that. So we have a players dot. You can see that there is a keySet method available for us. So this keySet method returns us all the keys, right? So we know that the keys are unique, obviously. So a set implementation makes sense here because it is also unique. So a keySet returns us the keys. So what we can do is we can get the keys. So what is the type of a key? Integer, right? So we can say it returns us a integer keys, right? So keySet should return us, set of integer, sorry. It returns us a set and keys. So all the keys are now stored into a variable called as keys, and after that we know that we can simply go for a enhance for loop, and then keys dot iterator is available. Then we can go for a key and then get key. So keys dot iterator, now it is available because it has become a set, right? So an iterator of type integer, iterator keys is equal to iterator of type integer, iterator, and then int key of iterator keys. Can only iterate over, so this is keys, that is iterator. Looks good. Let's see from where I have implemented that iterator. Java util iterator looks good. Keys dot iterator. Oh, while itr dot has next is something which I have to use, right? While with an iterator, itr keys dot has next integer itr keys, then do a, this is the key that I'm gonna get. Fine, and then simply what I can do is I can say system.out.println, print me the key plus the value as well. To get the value, we know that we have a method player dot get and then pass in the key there. So by doing this, we get the key as well as the value. So let's run this and check we get all the keys and values or not. So we are getting all the keys and the values. So this is how we can iterate over a map. Fine. So let's save it. Let's add this into the repository demo3. Iterate over a map using keySet. So keySet returns us what? Keys. So since it returns us the keys, we can take the iterator from it, or we can use an enhance for loop as well and iterate over a collection. So in the same way, if we didn't want an iterator to be used, and if we want the enhance for loop in this case, what we can do is we can say integer key of type what? Keys, right? So it will return us that, and then we can simply say system.out.println the key plus an empty space and then the value. So to get the value, we can say players dot get key. So by doing this, again we will be iterating over a map using an enhance for loop and a keySet. So in the previous example, I used a enhanced for loop. Sorry, I used a keySet and an iterator, whereas in this case, I have used a keySet and a enhanced for loop. When to use iterator, we have already discussed that into a list. If we want to remove an element while iterating over a collection, at that time we can use that, right? So demo for loop with keySet. Now while using a keySet, there is a limitation about the keySet. What is the limitation? The limitation is that the keySet is just giving us what? Just giving us the keys. It is not giving us the value. To get the value, we have to use a get method. We directly don't have a method called as the get value in here, right? So this is possible if we directly want to get the value, but that's possible using an entry set. So let's first go ahead and see how an entry set, how can we iterate over a map using an entry set. And also we can see which one is better. Entry set is obviously better than the key set. So I'll just comment this off first and let's see how can we perform an iteration using an entry set. First let's go ahead and again see the difference between a key set versus an entry set. So we have already spoken about the difference between the hash table and the hash map. Let's talk about the key set versus entry set. Fine. So an entry set contains both the key and the value. Get key and get value method are available there, whereas it's not available into the key set. Yeah. So keySet, this method returns the set view of all the keys present in the map. That is, it returns a set of keys. This method returns a set view of all the mappings present in the map. That is, it returns the set of key and the value pair. So because of which itself you can use both the methods, that is the key as well as the value. Whereas in the keySet you get only the keys. So if any changes happen to the map, then they can be observed in the set also, as set is backed by the map. For entry set method also, if any change happens to the map, then they can be observed in the set as set is backed by the map. So that is the similarity, not a difference there. So if iterating through all the pairs of the map using keySet, then the performance of the keySet is poorer. That's because we have to use a get method all the time, right? So compared to the entry set, as for each key we have to access its corresponding value by using a get function. That's what we have used in this example. We have used a get method. So every time we are calling a method, obviously it takes time, right? Whereas if we are using an entry set, at that time we have a get key and a get value method. So the performance is better. So because the performance is better, and if we want to retrieve the key as the value, always go for a entry set. Fine. So map.keySet, map.entrySet, that's the syntax. It does not take any parameters, so it has no exceptions. So let's go ahead and see how can we iterate using a entry set. So let's now take the entry set, which is players dot entry set. Now you can see that it returns a set of type entry. Entry set returns a set of type entry with the key and the value pair. Key type is integer in our case, and then the value type is string, right? So there we go. We got what? The entry. Fine. Now for again I'm using an enhanced for loop. I could use the iterator and do the same old thing that we have done before. Now I'm using an iterator. So I'll say entry is something which I want to iterate over. We know that enhanced for loop takes two arguments. The second argument is the array, right? And the first one is a variable of same type of array. The array type is entry, right? Entry set. So we can do this and then say entry. Let's call this as entries. Fine. And then we can simply say system.out.println entry dot get key plus entry dot get value. So we directly have the method get key and the get value. We are not using a method like what players dot get key for this, right? So because of which itself the performance is bit better comparing to the key set and has no exceptions into. Let's run it and retrieve all the elements. So there I want a space in between, so let's just add a space, save it, run it. So this way we can iterate over the map either by using a key set or by using an entry set. So by this set, which is of type entry set, do not be confused, because a collection can be a collection. That means collection can be a collection of collection itself. A list can contain, like we generally create a list of type player, or maybe a list of type string, list of type integer. We can create a list of type list, or we can create a list of type set, right? So if you remember, I gave you one example here, right? That is captain containing a player. So this map, when I'm creating this captain containing the players, so I will create this map like this, a map, a captain, name of the captain will be of type string, then player will be list of player. So this is all possible. This type of maps can be created. List can be of type list also. Fine. So collection, this key value pair can again be a collection within it. So we'll see one such example. So that's what it is. That's what the set entry set is all about. Set is of type entry. Of again, entry is a map again, which contains the key as integer and the value as string. So this map, the entry map, should be same as the map that we are creating. So because of which itself we can easily go for a get key and a get value. Hope this is clear to you. What I'll do is I'll copy this and put it into the repository once again, and I'll show you one more syntax for the same. Demo for entry set. So here I actually tried to make it simple by separating these things, because this is how we have been learning about the looping and everything. So what I can actually do is, let me clean up this. I can directly take this player dot entry set and put it here. Okay, and then what I can do is I can say this is the map dot entry, right? So I can say map dot entry, and I can do things like this. Same thing itself I am trying to do, nothing different. It's the same thing but done in a different way. That's it. Okay, so you might see examples online which are similar to this, not the one which I did. What I did was I simplified everything first, and then I gave you another syntax which could be similar to this. So entry set, this returns a set of entry, right? So that is the set of entry which is being returned here. So every entry will have a key and will have a value for it. So I'll copy this and put this into the repository. This is again an entry set demo 5. Sorry, demo 4 I have written twice. Demo 5 was this entry set, right? Demo 5 entry set, simplified you can say. Alright, so we created one type of map, then we traversed over a map using an enhanced for loop with a key set. Okay, because we cannot directly go ahead and iterate over it, because it's not a part of the iterable, right? It's not the part of iterable, that's why we did not iterate it directly. So we used a key set and we have used an entry set for it. Fine. So we can in future we will see how do we make use of a for each, which was again later introduced into Java 8. So we will see that example later, not here, because we still don't know what exactly lambda expressions are and what for each and all that is all about. So let's now, as we were discussing about the hash table and hash map, right? So I have used a hash table here, which does not allow a null value. Now let's have an implementation of a hash map with again same set of keys and the values. So you have a hash map created, save it, So it should behave the same, right? Behavior of it should be same. So the behavior is same, right? 118, 1045. Again, the order is not maintained, right? That's fine. Now what I will do is I will try to add the null values into this. So as we know that first of all, the hash map is thread unsafe, hash table is thread safe, so hash map will be fast. So I'm entering a null value. Keys can be repeated, no problem with the key. Thread save it and run it and see what happens. So you can see that the null key is added. Let's now check whether one single null key will be added or it allows multiple. So let's save it and run it and check. So you can now see that only one null key is allowed. Because of what? Keys are unique. Although you can put up multiple null keys and different values to it, but still you'll get only one. Fine. Allowed is like you can have more, but because the keys are unique, one null makes sense. And even the values can be null. So in this case, what I will do is I'll add one more and I'll put a null key as well as a null value. Null, which is not at all allowed into a hash table. You get the null key, you get the null value as well. So this is completely valid when it comes to a hash map. Demo 6 hash map. So let me write that here. Hash table is thread safe. Hash map is not. Because of which hash table is fast. Hash map is slow. Let's write it here. Hash table, hash map. Okay. Main difference is this thread safety and thread unsafety, because of which itself it is fast and slow. And hash table, no null key or value. Null key and value is allowed. Fine. So this is the main difference between the hash table and a hash map. Hope you're enjoying about the collections framework. And yes, as discussed, maps can be used when you want to maintain a key value pair in real world scenarios, things like this, pin code and cities, or team and player, captain and player, things like that can be created for maps. Fine. So in our next session, so in this session we basically discussed about what maps are all about, what is the data structure of a map, the key and the value pair. Then we talked about a hash table, which is thread safe, and then we talked about a hash map, which is thread unsafe. Then we traversed over a map. Because map does not belong to the hierarchy of iterable and collection, we don't have the methods like add. We have the method like what put to add the element into a map, and for retrieval we have a get. We have to pass in the key, we get the values. For traversing over a map, we have used two things. One is the key set, another one is the entry set. So key set returns us the keys, whereas an entry set returns us the set of keys as well as the values. So if there are any doubts, you can obviously ask me into the comment section. Do share the videos. See you in the next session. Thank you.